Now that we've had our introduction to forces and we know about how they make objects move, let's look at the biggest force that affects objects on Earth, which is gravity. Checking out the 2 essential questions I'll be asking you at the end. Make sure we know and understand the universal law of gravitation. So what do we know about gravity between all objects? And then also, what 2 variables can either increase or decrease gravity? So let's get our official definition of gravity and what it is. We know gravity pulls all objects down to Earth, right? But our official definition of it is gravity is the attractive force between 2 objects. And so the attracting is done between whatever the object is, say a ball, and Earth, right? And most of our information we know on gravity was introduced by Sir Isaac Newton. There he is. He gave us the definition and our formula that we're going to look at here. So what does Newton's law of gravity tell us? Well, it tells us that every single object on Earth that exists, having mass, which of course is everything, also has gravity. So an attractive force to anything else. And that pull of gravity between 2 objects can either increase or decrease based on 2 factors of those objects. It either depends on the mass the object is, so how much stuff it's made up of, or the distance between the 2 objects. So if either of those variables changes, either the mass or the distance in between, we see an increase or decrease in the gravity. And so our next part is understanding how that change will impact the gravitational force. So the force of gravity can actually be calculated using this formula given within the universal law of gravitation. This is a formula you want to write in on the right hand side, so go ahead and pause the video, make sure you get it written in, and then we want to know what each of the letters stands for in the formula. So our formula is this: F equals, which is the force of gravity, G, and then this is a little multiplication right here, G times 2 m's, m1 and m2, divided by d2. So you want to make sure you write this in on the right hand side. So thinking about each one of those variables, you want to know what it stands for. So like we said, F is of course the force of gravity. G, so this is what we're calculating for. G has the word gravity in it, but it's the gravity constant. It's the rate that all objects fall when gravity is impacting them. So the number is 6.67 times 10 to the negative 11. So that gives us a really teeny tiny small decimal. And that one actually will not change. That's a constant, so it'll stay consistent. D is one of our things that can change, which is the distance between the objects. And M is, again, something that can change, which is the mass of the objects. And we always have to have 2 because we're looking at the attractive force between 2 things. So we have the formula to tell us the exact amount of gravity between 2 objects, but we also want to know the relationship between the 2 variables that can change to get kind of a quick understanding if gravity is increasing or decreasing in certain situations. So this is looking at the relationship between those factors, right? Mass and distance. So one thing we want to think about is as the distance between 2 objects increases, so as objects get farther and farther away, what's going to happen to that gravitational force? The farther away those objects get, the weaker, or gravity decreases, that force becomes. And it's important to note that no matter how far apart the objects get, the force of gravity will never disappear. It will always be there. So even though I'm looking at planets that are millions of light years apart, they each have a very small gravitational force interacting with the other. So here we have a diagram looking at two scenarios, and we want to figure out which pair has more or less gravitational force. So the first variable that we're investigating here is distance. So when I look at these two sets, I've got a set that is far apart, and I have a set that is close together. So thinking back, I want to label which pair has more gravitational force and which pair has less gravitational force. So go ahead and do that on the right-hand side. The other half to our relationship then is looking at how mass plays a role in affecting the gravitational force between two objects. And so you see again a second pair of examples where we can see one has less mass and one has more mass. And what we're noticing here is that as the object's mass increases or becomes greater, it will also increase the amount of gravitational force. So bigger objects like the sun have a much stronger gravitational force on the Earth than smaller objects like a smaller moon or a smaller planet. Okay, so when we're thinking about the relationship between gravity and mass, the larger the mass, the larger the gravitational force. And that just works with general objects too. So again, you have the pair down there to label which pair has more, which pair has less gravitational force based on the factor of mass. So let's do a little application with the relationship between gravity and mass and distance by looking at these practice problems. So I'm telling you here that we have two stars that are equal mass 10 million kilometers apart. So I'm asking what's going to happen to their gravitational force if they start to move twice as far apart. So the distance here will increase and those stars become further apart. So if we think about that relationship, as distance increases, what will that do to the force of gravity? So you can answer that there, thinking about that relationship. And once more, looking at those same two stars, 10 million kilometers apart, if one starts to go to the next phase and becomes that red giant and grows in mass, what would happen to its gravitational force? So again, thinking about that relationship, if the mass also increases, what will we see in terms of a change in gravity? So fill in your best answer there. Again, look back up there. Look up there at those pairs that we labeled as either more or less to get a reminder of that relationship, and then practice. Then you can go ahead and pop to the back so you can work through some practice problems. Now that our notes are complete, we've got a summary section to do here. Notice that you have 2 writing questions and then a couple practice problems to complete. So read back through from the front, Universal Law of Gravitation, and hit me up with your best describe, including all parts of that. And then also, this one is not a describe, but you can just list out 2 variables and how they might impact the force of gravity. So we want to see the words either increase or decrease within your answer. Then checking out these practice problems, mostly they're coming right from your notes for starters, and then there'll be a few application questions as you go through. So as you work through these application questions, figure out, well, how is gravity going to be affected? Will it increase or decrease by the change in the factor that's being discussed? So you hear about both mass and distance changing, and I want to know, will that increase the amount of gravity between the objects or decrease? So no number answers just increase or decrease, and then a couple times sharing out a y. So as you finish out your video, your summary, and your practice problems, you've got a couple things left to finish out your digital learning day. First thing is to make sure that all your notes are completed on your worksheet. So check your right-hand side that you've got your formula and your examples labeled as either more or less. Second thing is you want to submit a picture of the back to Schoology so I can see your summary and practice problems got completed. And you can find that in the upcoming, or it'll just be called ES Gravity Notes. And then finally, the third thing is to check out the pop quiz, which will be called ES Pop Quiz. And then, of course, today's date is 4/24. So check that out. There is a timer here, so make sure you're ready and committed to sit for about 10 minutes and submit that picture and get the quiz done. Thank you.